to speak about theory of constraints, which is a theory how to optimize processes. First about me shortly, I've changed companies, mostly in software development. I personally developed software more than 20 years. Last couple of years in Closure, which is a more iconic language, Lisp language. When I don't program or develop software, I change the companies. Between my clients are automotive companies like Toyota, Peugeot, Citroën, Automobile, Skoda, Porsche, or for example, Carphone, Dixon's Retail, and others. So let's go to theory of constraints. Today we will begin with the basic theory. What's the theory of constraints? Then we will continue how this topic is relevant to software development and how to use theory of constraints, how to optimize the processes. One of the things I do with my clients is to make agile methodologies made to measure to the company. And each methodology isn't good for every situation, every needs, and so on. So the theory of constraints is one of my tools I use to improve the productivity of my client and improve, for example, when they use, for example, Scrum or XP. These both are very good methodologies, but not to end with. It's very good to start with them and improve them to something much better. So let's go to theory of constraints. There is one book. It's called The Go by Eliyahu Goldratt. It's the author of the theory of constraints. He wrote this book. It's a novel. It's not a technical book, let's say, and he hides all the methodology inside the book. Unfortunately, the book is a little bit fluffy, and you will lose a lot of time reading all the pages because it's a story about the plant manager who have a big problems with quality and productivity of people, and he meets an older man who becomes his mentor, who provides information and leads him to understand how the optimization process works. I will explain those principles in theory of constraints to you, I believe, in 10 minutes, so you will not have to read the book. But if you want, you can read it, of course. You can read it in one afternoon. So there is two things. First is improvement process, and the second is synchronization process. Let's begin with improvement process. It seemed very obvious in the beginning, but what I found is that most people know a lot of obvious things and still don't do those things. You still know that you should write tests and you don't write tests, right? You know that you should do some pair programming, you still don't do pair programming. And it's the same with optimizing productivity. The productivity, what do you think it's productivity? Do you think it's amount of work did in each single part, or the whole? It's the throughput of the whole plant or software development or any business you have. And the throughput of any organization is limited by a bottleneck. In book it's called constraint. I will call it today a bottleneck. And the most weak part, the bottleneck, limits the amount of work which is completed. And any time and any production which isn't delivered through the bottleneck is always lost. You can, for example, if you will, for example, work much faster in the part which isn't the bottleneck, before the bottleneck, it will lead to the situation when you have a lot of work in progress, and people who are bottleneck, for example, you have development process where you have analysis, development, and then you have acceptance by product owner, and the development is a bottleneck. In this situation where your product owner is creating a lot of stories and putting them to develop them in development, and development is a bottleneck, it usually is, but I will speak about it later, it leads to 100 kilometers long backlog because they are not able to handle it so fast. And each organization has a bottleneck, obviously. So first what you do is to find the bottleneck, and then you utilize the bottleneck 100% of the time. Why? Because when you don't utilize the bottleneck 100% of time, you will lose the production forever. When your product owner or somebody will go to vacation, he can still create a lot of tasks to product backlog, so the development still have a lot of things to do. I will use one more side note. I will use Scrum method terminology today, but all those things I will speak about can be used in any methodology, can be used not only in software development. They are already used in manufacturing, in mining, and other fields of human being. So, but when you, for example, have a bottleneck in software development, and the software developers do something different, when they are hired to develop software, and you force them to, for example, test software, the time which should be spent by development of software is lost, and is lost forever. So the next step is to utilize the bottleneck 100% of time. Then the third step is to increase the capacity of bottleneck. There are a couple of tools how to increase the capacity. I will show the examples in software development field later. So you increase the capacity of the bottleneck until the bottleneck stops being bottleneck, and then some other occurs. Because always there will always be one or two bottlenecks in your organization. 1, 2, 3, 4. It depends on how many processes or products you have. When you do only software development, you will obviously have only one bottleneck. It's impossible to have organization without bottlenecks. If you have non-bottlenecks, your organization would, or your productivity would grow ad infinitum. It's impossible. So you increase the capacity of bottleneck until it stops being bottleneck. Then you go back to the first point. You find new bottleneck, utilize it 100% of time. That's the first part of theory of constraints. And then there is a second one, and it's a synchronization process. It's called drum buffer drum row. There are 3 parts. Okay. There is somebody who is a bottleneck, Mr. Bottleneck. It can be a development department, test department, and so on. So this is the bottleneck. And then the bottleneck have some suppliers. So for example, it's a tester, or testers are a bottleneck. Suppliers are developers, and suppliers of that suppliers are, for example, product owners. Synchronization processes, Mr. Bottleneck, always when the bottleneck finishes the tasks, it drums a drum, which means sends a signal to a primary supplier, hey, I'm done with the item, send me another work. So if there was ideal flow, you wouldn't need no buffer in front of the bottleneck. Just after, or not after I finished, after I started. So after I started working on something, I sent a signal, prepare me another work. So they will prepare me another work, I finish it, and I ask for another, so I will get steady flow of tasks, and I would need no backlog at all. But unfortunately, there are fluctuations in the performance of different parts of development. So the developers are somewhere faster and slower, product owners are always faster and slower, go to vacation, there is some need of analysis, or you are waiting for a third party, and so on. So you need some safety mechanism, which is called a buffer. Buffer is just a list of items which are prepared for a bottleneck to take items to do. And the buffer should be as small as possible, but shouldn't be so small so that you will get into the situation that the bottleneck should starve. Bottleneck starvation is a situation where bottleneck have nothing to do. And this should never happen. In a highly productive environment, the weakest part should always work hard 100% of time. It's the primary primary rule of theory of constraints. So, after we prepared a buffer, we have implemented theory of constraints. Let's continue to describing the buffer diagram row. So the buffer has impact to time to market. As I told, you should have as small buffer as possible, because the bigger buffer is, the bigger is your lead time. The lead time is the time between product owner or the customer asking for something and getting something implemented. And when you have very, very big buffer, the items get to the buffer and wait there for a very long time. And then they get to the bottleneck and then move through the whole process and get to the production. So the too big buffer is very safe because you utilize your bottleneck 100% of time, and there is almost no chance that the bottleneck starvation will occur. But unfortunately, this is not very practical in business, especially today when we are speaking about continuous delivery, continuous improvement, continuous integration. Everything is moving to continuous everything, and we are trying to deliver instantly. A product owner asks for something and don't want to move or don't want to wait. And if the waiting is necessary, the product owner wants to wait only as long as it's needed. Of course, you can reorder items in the buffer. So when some item is very important, you can move some item from in the buffer to the top. But when you move items in the buffer, everything gets more complicated, and the inner items will have more longer lead time. So in the end, the average lead time will still be the same, and you will still be less responsive than is necessary. So one of the things is you should try to have as minimal buffer as possible. So how to size the buffer? There are a couple of approaches how to do a buffer sizing. First is experimenting. Then you can use the Scrum approach. Scrum approach is, I have iterations. Each iteration has, for example, 1 week or 2 weeks. So you always have a buffer of 1 week or 2 weeks, or somebody has 3 weeks. I saw implementation of Scrum with 2.5 days per iteration, but it's very rare. Most of the time it's 1 or 2 weeks. So you have 1 week buffer all the time. You can have a steady flow of tasks. I prefer that, and when I create methodologies for my client, I do a steady flow and I don't use fixed iterations. But we can begin with, for example, 2 weeks of buffer. So there is something like a sprint backlog, but it's sliding. It's sliding. It's still moving forward with the development, and we get it smaller and smaller. It's one of the approaches. And when you get it smaller and smaller, experiment. And when you get these fluctuations in productivity, you will get to the point where bottleneck starvation will occur. And when it occurs, you will remember and react instantly. Another approach is to use some best practices. One of the best practices is you should decide if it's small company or large company. This speech will be more about larger software development. It doesn't have to be absolutely great enterprises. It can be mid-size or large companies, but it's usable for startups and small companies as well. But for startups and small companies, they usually have a lot of concepts by nature, and they lose it during the time. So, for startups and small companies, you have product owner, and you have the longest time they unexpectedly missed for some reason. They were sick or something like that. And you add 2 days to this time. So for example, you know that the product owner was sick for 3 days. You didn't expect that, of course. plus 2 days. So we have a buffer of 5 days of work. And you slide the work of 5 days, and your time to market is time to deliver, time to implement something, plus those 5 days. In large companies, especially when those companies cooperate with another companies, third parties, and so on, I recognize that there are a lot of times spent doing analysis, both technical analysis and business analysis, and it can take weeks. And you take this average cycle time of analysis phase. Cycle time is a time to complete something of real work, plus 2 days. It's a best practice, so you can do this if you work in large company. Then there is another approach, which is called discrete event simulation. Who of you know what's discrete event simulation? One. There are a couple of types of simulations. There are agents, there are discrete event simulation, and so on. Discrete event simulation is very, very simple approach to do simulations. It's simpler than, for example, agent systems. It's less powerful at the same time. But these systems are good, descriptive enough to be able to test the system. So when you have, for example, a client or in your company, and you are not sure if you should do some change, you can always make a simulation of your processes. And when I meet a company who wants to do a change, and they are not sure if they should implement some change, they can always do a simulation of the current process and the new process and compare how they compare to each other. I use SynPy. It's a library in Python, which is very, very simple. So I will give you some gift for you in the end of this presentation, which uses the SynPy. And the last thing is statistics. Using statistics, I hired a statistic to prepare models and to do a buffer sizing for one of the clients. But unfortunately, this approach wasn't very, very good because he needed at least 150 experiments to have enough data to be prepared to prepare a statistic model. So statistics are usable too, but the data gathering phase is too long. So I wouldn't recommend this phase a lot. I think the best practice approach works very well. So let's go. How this is relevant to software development. We have a couple of processes during the software development. We have creating user stories. We have analysis phase. We have technical analysis and business analysis. We have development phase. Code review. Who of you do code review? Or who of you don't do? Doesn't do? No. It's a good thing that you do code review. I hoped for that. So you do code review. Then there is a testing. I mean testing with testers. A lot of companies today don't have testers. It's okay if you don't have. It's okay if you have. Then there is acceptance phase. Acceptance is accepting by product owner or the customer who accepts that the story is implemented well. And then there is a release. Let's first describe all those bottlenecks. So it's creating the user story. In the beginning, it's a good thing that when your user stories have similar task size. When you have different task size, I mean a similar like doable in 1 day, and it doesn't depend a lot if it's doable in 1 hour or 8 hours and so on. But it's a very bad thing when in your buffer you have tasks which are doable in 1 hour and in 4 weeks. You will have a big trouble to do a buffer sizing with such tasks because you will need a lot more analytics within your buffer. You will need estimates. Still, I think estimates are good, but it's a different topic. So I will not speak about estimates and no estimates and so on. So I think it's a good thing to have similar task size. Then, important thing in Scrum, buffer is the product backlog. In XP, buffer is the story pile. In another approaches, you must have some limit on tasks in, for example, Kanban board, but not limit on maximum tasks, but limit on minimum tasks in the first phase, or in the phase in front of, or just before the bottleneck. So there should be enough work for the bottleneck all the time, always. So this is the creating user stories. Usually, this isn't the bottleneck. Sometimes this is first in startups, because the direction changes every couple of days. So you are unable to plan for days or weeks or months in front to the future. Or in large enterprises. When you have large enterprises, as I told, the analysis phase tends to be very long, and people tend to spend a lot of time doing analysis, and it can lead to having those starvations of bottleneck. Then the third is that you have not very responsive client. When you develop software for anybody else, it's not your product, it's product for somebody else, and the person on the other side of the phone line isn't responding very frequently, or the time to respond is very slow. I worked with a client, it was an insurance company, and they responded, their response time for email was 3 months. And it was strange, because they had to have a couple of people speaking, go to another department, another people speaking, another department, then moving back, and so on and so on. It was very simple questions, and still, it took them 3 months, and the project wasn't successful. And I think the reason why the project wasn't successful was the response time. So in this situation, it's, if you will find a client like this, run away as fast as possible. It's impossible to deliver software for such clients. Okay, so let's go. There is an analysis phase. You can have a bottleneck in business part or technical part. As I told, usually in large enterprises. Then there is a development. Development is a usual suspect. It's usually the bottleneck is the development. It doesn't have to be always, but usually when I optimize company, it is a software development department. So those people are hired to develop software, and most of the time, what's necessary to improve productivity of software development is to let software developers develop software for more time and do other things for less time. And let other people to help them to do parts of their work. I will speak about that later. And don't forget reward, like tasks which go back from code review or testing. You should count all this time to the capacity used by development department. Then there is a code review. Code review consumes development resources. Usually, it's not a bottleneck. The code review isn't usually a bottleneck, because these are the same people who develop the software and then do the code review. So usually, the bottleneck is in the phase before, in development. But I found companies where they had this process where not everybody can do the code review. For example, only senior developers can do code review, which can lead to the situation where most of it was summer, right? And most of the senior developers were on vacation. And there were only one senior developer which had the right to do code review. So in this situation, you had many normal developers. I don't like calling them junior or senior. More experience, less experience is better. So you have a lot of less experienced developers which weren't allowed to do code review. So one of them, the only senior developer, was the bottleneck. He was working 100% of time to do code review and still wasn't able to deliver all code reviews it was necessary. So it is the situation where code review can be a bottleneck. But it's very rare. It's very rare. Then it's testing. Testing usually is not the bottleneck, except the situation when you have a regression testing. I hate regression testing. Each company which has a regression testing will feel a pity later for that, and will feel a lot of pain for regression testing. What's much better is continuous testing. I will speak about it later, but still, I speak about it for the second time. It's continuous. Today we are doing everything continuous. And then there is an acceptance phase. Product owner, of course, can be the bottleneck. Very simply, product owners can very simply become the bottleneck. There is one problem with product owners, and it's that product owners have three qualities. And each product owner or customer or product manager, it doesn't matter how you call it, must have three qualities. The first quality, the product owner must have authority in the company. To be a manager or to be a director or somebody like that, to have authority, to have deep understanding of the domain of the software development, or not software development, of the domain of the system. So when you have an insurance company, it must be a manager from insurance company. It doesn't have to be manager, but somebody with authority, and must have enough time. And usually, you have business analysts which have domain knowledge and have time because they're hired to have time, but they have no authority. Or you have managers who have authority, have deep knowledge, but doesn't have time. So it's a huge problem. In this situation, what you need to do is to hire more product owners, or move the authority to business analysts. I will speak about it later as well. So these qualities are problem when you are trying to solve the problem when you have a bottleneck in the product owner department. Okay, and then there is a release department. It usually is no problem. A couple of years ago, it was the deployment process was like I start a total commander and copy files to server or something like that. Now we have provisioning software, Salt, Ansible, and so on. It's getting better and better. And still the exception are large enterprises, because they have very complicated infrastructure. They use a lot of technologies. One of my clients have 3 Java application servers, JBoss, WebLogic, and one more, I don't remember exactly. Use IBM DB2, Oracle, and Postgres. Microsoft Fast is for full text search. When you want to release and other technologies, when you want to release to all those technologies, it's very complicated. The developers made a release on one click. They made a one-click release. They click a button in a continuous integration system, and one floor below in operation system, the light goes green, and it means release, and they will start releasing. So they have one click, they have a human API. But unfortunately, that release process is still error prone and takes a lot of time. So it is one of the situations, where the release process can be the bottleneck, and the way how to solve it will be shown later as well. So What should we do? There are a couple of approaches how to do software development. You can do all the development in a couple of phases, so we will. First, create user stories, the analysis, then the development, then the code review, testing, acceptance, then release, and it's finished. Or we can, for example, do code review and testing together, and which one first finds a bug in the code or in the solution, reverts it back to in progress phase. Or we can send it to code review, testing, and acceptance at once. I think none of you never imagined it's possible to do things like that, right? But if product owner or testing departments are not the bottleneck, it can really help, because the developers who are doing code review don't have to do code review, so the development will be faster, right? So what's the right approach? So let's go to examples. We have a team. We have product owner, we have a developer, tester, and operations guy. Product owner creates the tasks, developer asks questions of product owner, then developer, after finishing, do a code review and send the task to test. Tester tests the task and send it to acceptance to product owner, and then product owner sends the task to operations. This is the normal process, and in this process, let's go to improve this process by going through all possible bottlenecks. So, first one is product owner. So, what can we do is to change product owner's priorities. It can be done in very, very big companies only. If you have mid-sized company, the product owners are usually managers so important that you can't change their priorities. It can be done in enterprises with thousands of employees, like SolarWinds and so on, where you can, where your product owners are only technical managers of the first line, so you can change their priorities. Or you can add new product owners. The problem is that they have to have those three qualities. Or we can add business analysts. So it's improved process. It seems quite complicated, but don't worry, I will explain to you. So there are two traces in this graph. So first, we have one product owner, and he or she creates raw tasks. I call it super user stories, or I call it epics, doesn't matter. Product owner sends it to business analysis, and after creating user stories by business analysts, it goes to developer, who asks questions to product owner or business analyst. Then it goes to code review, it goes to test, and it goes to an acceptance by product owner. And product owner can reject that, of course, or can send it to release. Or there is another approach. You have a product owner, and you have product owner proxy. Product owner and product owner proxy approach is good in situation when you have international company on many continents. And when you, for example, have product owner which is in the United States, and and the team is in Europe, and there is a 7 hours time span, product owner proxy in Europe is very usable. It's very usable, and it can help a lot. So in this situation, product owner is a best solution. Business analysts are a good solution when the problem, the domain is very complicated, like banking. Banking systems are quite complicated. You must handle systems with millions of lines of code. A lot of this code is legacy code, which is absolutely horrible. When I saw source codes of bank systems, I began to be afraid for my money, and you should be too, because those source codes are not very beautiful, very often. So this is the approach when creating tasks. Then the development is a bottleneck. When the development is a bottleneck, you can hire technical analysts, testers, test the solution before it goes to code review. Product owners and others learn the basics of SQL or something like that, so that the developers doesn't have to do reporting and simple maintenance, because people are able to do it themselves. And then the development process is almost the same, only the technical analysts get the tasks and send it to the developer, and we change the order that from developer it goes to tester, and then it goes back to code review, and it goes to acceptance from developer. Another situation is when a tester is a bottleneck. Then you do code review first, you do a lot of test automation. It's absolutely economical, sustainable, and it's a good thing to do a lot of unit tests, a lot of testing in this situation. You have testing developers. I have this text involved, and they hate it. Developers hate to test, but it's a good thing to do, because it increases the capacity of bottleneck, so it increases the throughput of the whole organization. And you have continuous testing instead of regression testing. So the development is the same as usual, except that the tester signals that the bottleneck occurred. The tester is on the top of the capacity and cannot handle more work, and the developer will test the work and then send it to product owner if the developer tested the solution. Then, if acceptance is a bottleneck, then you have a business analyzer who creates user stories from super user stories. Review and test is first, and you have PO proxies, so it's the same process as I showed before. And then there are operations. When operations are bottleneck, the DevOps can be a solution. So developers can do a part of the work of the operations. Then the second thing is to limit used technologies. I know that developers, and I am a developer too, love to do a lot of new technologies, to try new things and so on. But in this situation, when operations are the bottleneck, you must limit those technologies to use one application server, one or two programming languages, one cache, one database. To limit that, and it will make the situation for operations much simpler, and it can cause operations stop being bottleneck. So now, the only change is that we made a provisioning system, and the development and operations both can update provisioning scripts or provisioning configuration files. So you increase the productivity of operations because, or you didn't increase that, but you increased the throughput without actually increasing their productivity, right? So we come to conclusions. Right approach can increase the productivity of development by tens of percent, really a lot. But for example, this approach using DevOps in situation when your development is a bottleneck, and trying to force your developers to do DevOps means that they have less time for development, and it can actually harm the software development. So, good intentions doesn't have to actually improve the situation. Be very careful about thinking about the situation in your company. And when you are not sure, I will speak about it for the second time now, use discrete event simulation. It's quite simple. It's much simpler, and you don't need so much data when you, in comparison, doing statistic models. And yeah, I will show you something later about the discrete event simulation. I'm running out of time. Tips and tricks. Hire to the bottleneck or to the helping roles. And it can increase your productivity linearly. You add one person and it linearly increases your productivity. Do meetings and everything they have to do, the people in bottleneck, everything they have to do which isn't really the work they are hired for, it should be as short as possible. And sometimes anti-patterns are allowed in the bottleneck, like higher specialization. We are trying to have people, we call it full stack developers, right? People who can do everything. In the bottleneck, high specialization isn't always the problem. Sometimes when you have highly specialized people who are very productive and can do their work very fast, it can really help the bottleneck and can increase the productivity and can give you competitive advantage you need. But be aware of the technical depth in the bottleneck. Don't let it grow too much, and you should have some kind of refactoring. Refactoring is a term from development domain, but something like refactoring can be done in your backlog. You can prune your backlog, improve your format of user stories. You can do the same thing in operations and so on. So, takeaways. Find the bottleneck and impose 100% of utilization. Help your bottlenecks all the time. In situation where the development is a bottleneck, most of the time it is, help the development. Ask other people who are not developers to do the task which they can do even when they weren't hired for that, because it will help the throughput of the whole organization if you are a software development company. If you are not a software development company, of course the situation can be much more complicated. When you are not sure, do simulations. It's not so complicated as you might expect. Feel free to contact me. I have a website too, in English it will be in 1 month, I believe, so in Czech language, I'm sorry for that, but I'm working on a translation. Now, if you want to try a simulation, I prepared something for you, and it's a simulation of the first process, like this one. So if you will try or you will want to do some simulations, and if you know how to develop software, you can do your experiments. It's on Bitbucket. You can download it here. You need 3 libraries. Pika, it's an actor model library. Flask, it's a web framework, and SymPy, it's a simulation framework. Let's show. So, we have the process, and let's start the simulation. You see the numbers are changing. It is the simulation. I used some statistics, some random time of the tasks, how much time was necessary, and so on. And now it's finished. You see the numbers are not changing anymore. And then you see in backlog there are only 12 tasks. It's not necessary that there are 2 numbers. But in progress, there are 3,615 tasks, which means this is the bottleneck. In this situation, in my simulation, it's not necessary to show the source code, but I only want to show you it's not very long. That's it. 160 lines. It's a whole simulation. You have resources. It is product owner, developer 1, developer 2, tester, and operations guy. Containers, which are backlog, in progress, to review, which are basically phases of the tasks. And then you have a couple of processes, and then so on. And you have your simulation. So feel free to download that and to do your simulations. And if you would like to have more content on that, I plan to write more articles on productivity of software development. So feel free to write me on my email, and I will write you back. Thank you very much.